Okay, there's exercise 1.05 sampling techniques. Now, you've all seen the word census and sample, and we know that a census is when the entire population is included. So it's when everybody is asked, okay? Now, if the whole population is too large or too difficult to survey, we will take a sample of the items from the population, and we can then draw conclusions from those results about the whole population. However, it just depends on how well you take that sample of the population. If that sample is biased, then you're not going to get a very good representative of the population. So, just comparing sampling versus taking a survey. A sample is when you just survey a group of items from the population, and it has to be a representative group. So it can't be just a certain group that's not representative of the whole population, okay? A census is when we survey all items in the population. A sample will just give us an estimate or approximate information about the population, whereas a census will give us exact information about the population because everybody has been asked or every item has been sampled. And a sample is simple and not expensive, whereas a census is complex and expensive. All right. Now, there are the way that we can take our sample, we're going to look at three methods of taking a sample. Now, the three main types. So the larger the sample, obviously, the more accurate the results will be, and the more that the sample is representative of the population. Okay, so meaning that each item in the population must have an equal chance of being chosen, the better, the more accurate that the results will be as well. So there are three types of samples. We can have a random sample, a systematic sample, or a stratified sample. Now, in a random sample, it's like you're choosing a name out of a hat or a name out of a box. However, you can use your calculator or a computer to create a random sample. For example, here I've just done a search on a random number generator. Let's say we have 30 students in a class and I want to choose 5 people. So I'll start again. So actually we've got 18 students, I think, in our class, and I want to choose 5 students. So I go minimum 1 if I just get the order on the roll, and maximum 18, and I click generate 5 times. I'll choose the first person, the second. That didn't seem random, but it is. The 15th. Oops, sorry. The 5th and the 6th. Okay. So then I might have 30 people, and I'll try it again. So 8, the 24th person, the 11th, the 27th, and the 17th. Okay. So that's an example of a random number generator. There is also a function on your calculator to do that. Okay, now in a systematic sample, the first item is chosen at random, and then other items are chosen at regular intervals. For example, there might be a factory line making mobile phones, and the first item is chosen at random, and then every 20th mobile phone, for example, then is taken for testing. Or if there's RBT, random breath testing, on the road, they might choose every 8th car on the road. I don't think they tend to do that, but they do tend to take a group, but they might do it at so many minute intervals or stuff like that, okay? So it's like I might look at the roll of the class, and let's say I want to choose 3 people from our class. I might just say randomly choose the first person, number 6, and then I might choose every 4th person after that on the roll, for example. So if I had the 6th person, then I might decide to choose the 10th and then the 14th person. Okay? Yeah, so we could do that as well. So you're following a system for choosing your sample. And in a stratified sample, the population is divided into strata or layers according to some characteristic. So for example, gender or age group. Age group is a good one to look at, or year group, for example, in our school. Let's say we've got 700 girls in the school, and if we have more, say, year 10s than any other age group, we would be choosing more year 10s than other age groups. It might only differ by a couple of students, but you have to choose it in proportion to the number of students in the population. Okay, let's say year 8 is the smallest group, we'd have less year 8s being chosen, but it has to be based on percentages or fractions of students of the whole in each year group. So, for example, if 28% of all shoppers in Australia are male, then if we want to take a sample of shoppers, then 28% of those shoppers must be male. And the other 72%, because 28 and 72 makes 100, the other 72% would have to be female. Okay, so when you think of the word stratified, remember, you've probably seen that in science or, geology, and it's like a rock has got different layers in it, and you can see the different types of rocks in a cross section. Okay, so it's like stratified rock. In Bethlehem, if year 7s, there are 112 students. Year 8s, I'll just draw up a table, there are 110. Year 9s, we have 119. Year 10s, we have 121. Year 11s, there are 116. And year 12s, we have 123. And the total, if we add all those up, we get 701. Okay, let's say we want to take a sample of, 70 students. Let's say we want to sample 10% of the population. So I want to sample 70 students. Okay, so we have to make sure that we've got the correct, obviously we want the most year 12s and then year 11s, but they may be, or year 9s are very similar as well, but we'd probably have a few less, or even, with rounding, there's probably not going to be much difference in the number of students we select. But the fraction of students that are at year 7 is 112 out of 701. So we go 112 divided by 701 times 70. Now that will give me the number of students in year 7 that I should choose. In year 8, it would be 110 out of 701, because that's my fraction of students in year 8, times it by 70. Okay, now you may get the same number of students because of rounding here. 119 over 701 times 70, etc. 121 over 701 times 70. Look, the year groups are fairly similar. 116 over 701 times 70. And the last year 12 group, 123 over 701 times 70. Now you've just got to be careful with the rounding of these. Okay, so I'm just going to work them out. You're just rounding them to the nearest. This would round up to 12 and this would round down to 12. If we add these all up, we can see that we do get 70. Okay, so we would have 11 students from year 7 and 8, but then 12 from each of year 9, 10, 11, 12. Look, there isn't much of a difference. There's only 6 students difference between the highest and the lowest here. But, that's how you would create or choose your stratified sample. And then within, say, year 7, you would choose those 11 students, perhaps using a systematic sample or even a random sample. Okay? Exercise 105, we'll just work through these and then I'll just set you some homework. So determine whether sampling or taking a census is more appropriate. If you want to count the number of students who are learning Japanese at a school, well, you need to know about every single student. That would be a census. The number of people who watch soccer on SBS TV, that would be very difficult to work out the exact number. You would take a sample. Judging the most popular supermarket in a town, again, that would be a sample. And finding the number of Australians who were born in Europe, census, because you need the exact number. Okay? And also that's easily available from census information. Okay, now, question 3, the appropriate type of sample. Would we choose a random, systematic or a stratified? For each of the following, giving a reason. Testing running shoes for quality. That would be best as a systematic sample. Okay, because you'd maybe take one sample every half an hour off the processing line or even more regularly than that, okay? That way you're able to see during the whole production of those shoes whether there is good quality and, I suppose, consistency. And again, you'd need to know during the entire shift of making those shoes that whether the quality was there. Okay, finding the most watched TV station on Tuesday nights. That would be best to take a random sample there. So taking a random sample would hopefully get all different areas that you were of the population, all different suburbs, etc. Okay, all different age groups if it was random. Testing the reading abilities of a school's students. Now you need a good sample from all the year groups, so that would be best done using a stratified sample because you need a sample from all year groups, and also in the percentages that there are in each of those year groups, okay, in the correct percentage or in the same percentage according to the population distribution. And part D, testing a new drug on patients. That would also have to be a random sample, okay? That way there'll be no bias, okay? And hopefully different age groups and, people from people living in different areas as well, okay? All right. Question 4, a department store has a customer database of 3,347 male shoppers and 1,504, female and 1,504 male, and it wants to introduce a new credit card to a stratified sample of 200 shoppers. How many females? Now we need to look at the fraction that are females, just like we looked at in our example of the school population. We've got 3,347 females out of, we need to know the total shoppers in the database. So that's 3,347 plus 1,504, just adding them together, we've got 4,851 shoppers. So the fraction that are female, we know it's more than half, obviously. So we just add those two together, 3,347 plus 1,504. That's 4,851, so 3,347 divided by 4,851, that's the fraction, and then we times that by 200. And we get 137.99, which approximates to 138 female. And so therefore the male shoppers, you can just do 200 minus 138. We can just do the fraction again, 1,504 divided by 4,851 times 200. We should find that we get 62. So 1,504 divided by 4,851 times 200 gives me, 62. And if you add up 138 and 62, you end up with 200 shoppers. So we need 138 female shoppers. And now for question 7, explain why each of the following samples is biased. A sample of Dolly magazine readers was surveyed to investigate teenagers' views on road safety. Well, that is biased because not all teenagers read Dolly magazine. Okay, and also that would be more biased towards girls as well. There would probably be no boys, or hardly any boys that would read Dolly, okay? So more biased towards girls, and not all teenagers read Dolly as well. So B, diners at a restaurant can give feedback about their meal by filling in a survey and posting it on the internet or to the internet. Here, often when people are given surveys, not everyone will fill it out. Everyone will fill out the survey. So it's really biased because it's only going to be a sample of the people that want to fill out the survey. So not everyone will fill out the survey, so it's not really representative of the entire population. And part C, for a survey about canteen food, the school council interviewed the first 20 students to arrive at school one morning. This is not representative of the entire population. it only has students that arrive early. It's also just the first 20. It might be better to use a systematic sample. It might be, for example, every 20th student that might walk in might be better, or every 10th student that walks through the gate. And also you probably need a larger sample size as well. 20 is not enough, not for a whole school of say 700, okay?